All right, so this is an informal definition of a limit, but ideally what we're talking about is that if f of x grows large for all values of x close but not equal to we can write that the limit as x approaches a of f of x is equal to infinity. Now, this can also be true if we go ahead and replace the word large with f of x goes negative but larger in magnitude, meaning the absolute value of f of x, then it would equal negative infinity. However, it's important to note that both of these, even though we say that the limit approaches either infinity or negative infinity, the limit itself does not exist. So when you're answering questions like this, do answer them where you are talking, it approaches either positive infinity or negative infinity, but technically it doesn't exist because it doesn't actually get closer to infinity. You can't. Infinity is an idea. We're just saying that this limit in this function is getting infinitely large. Infinite limits occur at vertical asymptotes, and just as a quick review, any function that you have that would be written as the numerator of x over the denominator of x, where n of x and d of x are both polynomials. To find the vertical asymptotes, wherever the denominator of x is equal to 0, the function is undefined. And a vertical asymptote exists. Let's go ahead and take a look at this graph. We have a few things going on. The graph in white here, this is g of x. We have two asymptotes. They occur at x is equal to 2 and at x is equal to 4. So let's go ahead and examine a few limits. All right, so if we go ahead and look at this as x approaches 2 from the positive side, that means we're coming in from this direction, right? So we are over here. So what we're getting at this point, as I'm approaching 2 from the positive direction, I'm coming down here and I'm approaching negative infinity. Now, if I come at it from the other direction, the limit as x approaches 2, but from the negative direction, now this time I'm going, and this graph is getting larger and larger. And again, remember the definition is it is getting close to a, and in this case my a is 2, but it doesn't ever equal to. As I'm getting closer and closer, this is getting to a larger value of g of x. So this one is equal in approaching a positive infinity. Now, what about the actual limit? The actual limit as x approaches 2 of g of x does not exist. Now, let's go ahead and look at the next asymptote. The next asymptote we have occurs at 4. So let's go ahead and look at the limit of g of x as x approaches 4 from the negative side. We'll start with the negative this time. So on the negative side, we're coming in like this. Excuse me. We're coming in on this side. Negative means less than 4, so I'm coming over here from this side. So that is going to approach a negative infinity. I do the same thing, but my limit as x approaches 4 from the positive side of g of x. So this time I'm coming from the positive or larger value of 4. That also gives me negative infinity. So I can go ahead and say here that the limit as x approaches 4 of g of x approaches negative infinity. So while the limit itself doesn't exist, we say the limit approaches infinity. If you answered did not exist, you'll be wrong. The limit approaches negative infinity for the asymptote at 4. All right, let's go ahead and look at 2 more examples. So if I look at the limit as x approaches negative 2 of f of x. Now, notice with this, I do not have a plus or minus, so this is both sides of negative 2 must approach the same place for this to exist. So if I go through and look at the left-hand side, you'll see it is getting sufficiently large and approaching negative infinity. Same thing if I go ahead and come at it from the right hand or the positive side, also approaching infinity. So I say this limit is approaching negative. Again, we say this limit approaches negative infinity. Now, if we go ahead and look at the next limit, where there's an asymptote, and that is when x approaches positive 5 of f of x. So we have to look at both sides of it. So as you are coming from the negative or the smaller side, the left side, it approaches positive infinity. As you're coming from larger than 5 or the right-hand side, it also approaches positive infinity. So that also would tell us that this limit approaches infinity. So as you can see, to summarize what's going on here, if on both sides of the asymptote they're going in the same direction, in this case the direction is going towards negative infinity, the limit approaches negative infinity. If both sides of the asymptote go up, in this case it's approaching positive infinity, the limit at 5 is approaching positive infinity. If you have a case where the left hand and the right hand side do not agree, and what that would look like would be a graph like this. The limit of this function, let's call it h of x, the limit as x approaches negative 5 of h of x, this does not exist. It does not approach positive infinity or negative infinity. It approaches positive infinity on the left-hand side, and it approaches negative infinity on the right-hand side. So this limit straight out just does not exist.